Hello everyone, welcome to the session. I am Satish H, Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. So today in this session we are going to discuss about the subject, the elements of mechanical engineering, in which we will be dealing with the topics or the contents under module number 1. So the different contents or the topics that we are going to cover in this session are the modes of heat transfer. So here we will discuss about what is meant by the energy, what is the forms of energy, and then what is meant by heat, and then the different modes of heat transfer. In particularly, there are 3 modes of heat transfer, that is conduction, convection and radiation. And later we will go to the steam formation. So in this we will, with the help of an experiment, the steam formation experiment, we will try to discuss about what are the different properties of the steam, so etc. So similarly, what are the types of the steam we have? So we have the different types of steam, like a dry steam, wet steam, and then what is meant by the superheated steam. So under the topic of types of steam, we are going to cover those things. And what are the different steam properties? Now, the steam has different properties like the pressure, it might be the volume or the temperature, or we have the enthalpy or the internal energy. So we will be going to deal with or discuss about what are the different properties of the steam, okay, for different types of steam, for example wet steam, dry steam and superheated steams. And then later we will discuss about what are the applications of the steam, where all we can make use of this steam. So that we will discuss in the next talk. And then at the end of this topic, we have some of the numericals, okay, which are used to calculate the different properties of the steam using the steam tables that we are going to discuss at the end of this session. So coming to the first topic, that is the modes of heat transfer. So before going to the modes of heat transfer, we will try to understand what is meant by the heat transfer. So actually the energy is defined as it is a capacity to do the work. So we say that everything around us is an energy. So what are the different forms of energy that we are existing in the nature? There are various forms energy is existing. So for example, it might be an electrical energy, or the energy can be existing as like a potential energy, kinetic energy, and then thermal energy, nuclear energy, solar energy, wind energy. Like this, in nature there are energies available in the different forms. And also we know that one important postulate, that is energy cannot be created nor be destroyed. It can be only transformed from one form to the other form. So it, like for example, the mechanical energy can be converted into the thermal energy, okay. So we cannot create the energy or destroy the energy. We can only convert one form of energy into the other form of energy. So when we are discussing different forms of energy, so thermal energy is one of the energy, or the heat energy what we call. So it is one of the form of the energy. So what is mean by the heat transfer? Okay, so in order to heat transfer to takes place, so we need one condition, that is there should be a temperature difference between the hotter region and then the colder region. Always the heat transfer from the hotter region to the colder region, and then otherwise we can say that so heat is transferred from the higher temperature to the lower temperature. So there should be a specific the temperature difference, okay, between hotter region and colder region. So then with the heat transfer can be taking place. So in what ways the heat transfer can take place? Alternatively we can call it as modes of heat transfer. In the basically 3 ways the heat can transfer. One is the conduction, convection, and then the radiation. So we will discuss one by one. What is meant by the conduction? Okay, so conduction is the transfer of heat, okay, from the hot region to the cold region. Predominantly the conduction takes place in the case of the solids, or when the two bodies in the contact with each other. We know that the matter, whatever the matter we take, if you take the solid, it made up of molecules. So here inside when the conduction is happening, there is no movement of the molecules is happening. Then how does the heat transfer in a conduction takes place is, it is because of the vibration of the molecules about their mean position, because of which the conduction will be taking place. So now let us look at one of the example for the conduction. If you take this pen and then imagine this is a metal rod, and then I will hold this metal rod in my left hand, and then at the right hand I will start to heat up this right hand using some candle or anything. So we know that, so after some time, so you start to feel the heat in your left hand fingers where you are holding this one. So what happened, let us try to analyze. You are heating this end, so it becomes, the temperature of this part of this body will increases, and then this is at a lower temperature compared to this end. So the heat starts to flow from higher temperature to the lower temperature, and then you start to feel the heat at the other end. So this is an example for the conduction heat transfer. So the second one is the convection. So the convection happens predominantly in the case of the fluids. When I say fluids, it also means the liquids and gases. The example for the liquid is the water, and then example for the gases is we can take it as the air, the atmospheric air around us. So in the case of the convection, the heat transfer from the higher region to the lower region so will happen. So inside the liquids or the gases is called as a convection. So the convection can take place maybe due to the difference in the densities, okay, that we call it as like a natural convection, or like in the case of a forced convection where we force the fluid, because of this the convection might be taking place. And then example for the convection is, okay, if you have this hot cup of the tea and then you keep it on the table, after some time you just check the temperature of the hot cup of tea. The temperature of the tea would have been reduced to the room temperature. What happened to the temperature of the tea is the temperature or the heat which is lost to the surrounding air. So because of this, until the room temperature is reached, okay, so this is an example for like a convection we have. So also the convection can take place when the molecules move around. So and also because of the convection can take place because of the density differences. And then one more mode of the heat transfer is, it is called as a radiation heat transfer. As I said before, solids like in the case of a convection and then the convection, we need a medium for the transfer of heat to take place, and also the temperature difference. But whereas in the case of the radiation, so the radiation doesn't need the medium, the radiation can also happen in the case of a vacuum. So the radiation happens in the form of electromagnetic waves. Some of the examples for the radiation are, so we know that the sun, the energy is coming from the sun. The sun is considered as a primary source of energy. The energy from the sun reaches to the earth's surface in the form of the light and then the heat, okay, through the electromagnetic waves, okay. So this is an example for the radiation heat transfer. Or if you take like a microwave oven, so where we heat the food, so that is also the phenomenon because of which the food is getting heated up is because of the electromagnetic waves transmission, that is mean by the radiation heat transfer. So that is about the different modes of heat transfer, that is conduction, convection and then the radiation. Let us go to the second topic, that is the steam generation. What do you mean by the steam generation? We know that water is a pure substance. So what do you mean by the pure substance is, in all the three states of its existence, the water can exist as a solid in the form of ice. Water can exist as a liquid in the form of, like for example, water. And then water can also exist in a gaseous form in the form of a steam or the vapor. So the pure substance is one in all these three different phases, that is solid, liquid and then the gases. Its chemical composition doesn't change. That is like a meaning of a pure substance. So when the ice melts, it is converted into the like a water. When we heat up the water, water, by absorbing the heat, it is getting converted into the vapors, or we call it as a steam. So steam is having a different properties. For example, the pressure, the volume, the temperature, internal energy, and then the enthalpy are some of the properties of the steam. So with the help of a steam generation experiment, let us try to understand all these different properties of the steam. So in the case of steam generation, we have taken a cylinder. This is a cylinder we have, and then we have taken 1 kg of the water inside this cylinder, and then above the water we have a movable, frictionless, the piston. Okay, this is the movable frictionless piston which is above this water, and then we have applied a certain weight. You can see this in the sketch. W is the weight of the water. So, and the water is at the 0 degree centigrade, and then the volume is V. Okay, so this is what we have taken. So in the steam generation experiment, why we have the piston, upon the piston, why we are applying the weight is, we are conducting this experiment at the constant pressure. If you have a certain weight, okay, so that means a constant pressure is applied on this water. Okay, so that is why we have taken this W. So, and also in order to understand this, we have this temperature enthalpy diagram we have taken. So what is mean by the temperature enthalpy diagram is, this is a XY plot. On the x-axis we have the enthalpy, on the y-axis we have the like a temperature we have taken. So while discussing all these different stages of steam formation, we will also locate or try to understand on the TH diagram. When I say TH diagram means it is temperature enthalpy diagram, because H is nothing but the enthalpy of the steam. So here the condition where we have taken 1 kg of the water inside the cylinder, upon which a frictionless piston is mounted, and then upon which we have the weight is taken at 0 degree centigrade, it corresponds to the point A on the TH diagram. So we try to supply certain amount of heat, okay, to this like a water which is 1 kg of water, and then by absorbing the heat which is by the water which is at 0 degree centigrade, the temperature of the water starts to rise gradually, and then up to like a saturation temperature, or the when the boiling point of the water is reached. So here you take this A, which is the starting point of this experiment, that is water at 0 degree centigrade. You are supplying the heat, and then it is the temperature, like you can see this is the y-axis the temperature, and then the temperature of the liquid is rising until it reaches the boiling point of the water, or it is called as the saturation temperature of the water. It is represented by the point B. And then we have this saturation temperature which is represented by Ts. What do you mean by the saturation temperature is the temperature at which the water starts, or the liquid starts the boiling. So that is called as, at given pressure, that is called as a saturation temperature. So that is represented by the Ts. On this diagram it is represented on the graph, in the TH graph, as the point B. And then what is this line AB is, it is the heat addition. Okay, so in order to convert the water which is at 0 degree centigrade to the Ts degree centigrade, or the saturation temperature of the water. Okay, that is what the line AB represents. And then we have something called as a sensible heat, okay, which is represented by the HF. What is mean by the sensible heat is, we are constantly heating this water, so it is the amount of heat required to rise the temperature of the water which is at 0 degree centigrade. It is the amount of heat required to rise the temperature of the water which is at 0 degree centigrade to the saturation temperature. It is called as like a sensible heat. It is represented by the HF. So that is the point AB and then the B. So we are here, and then when this happens, when the water is being heated from 0 degree centigrade to the saturation temperature, the volume of the water is also going to increase. Okay, if you look at this sketch and this sketch, this is this much, and then piston is moved little bit like in the above direction. That means volume V is changed to the volume Vf at the point B. If you keep on adding the heat, you keep on supplying the heat, after this saturation temperature, the water starts to vaporize. So water starts to vaporize at the saturation temperature. One of the speciality of this like a point BC is that the saturation temperature remains the same until all the water is converted into the vapor. So all the water is converted into the vapor. Until that, the temperature is going to be a constant. So you can look at this. From A to B we have heated, the temperature is gradually increasing, and from B to C the temperature is constant, and also the pressure we already kept it constant. Okay, so this is what we have, that BC is the constant temperature, constant pressure, okay, vaporization process. So, and then we have something called as the latent heat. What do you mean by the latent heat? It is the amount of heat supplied to to convert the water, okay, which is at saturation temperature, to the a dry saturated steam, which is also at the saturation temperature. So that is called as a latent heat, which is nothing but a HFC, which is represented by the HFC. Okay.